Welcome to the Stormsurf video surf forecast for the week starting Sunday, April 10th. Looking at significant wave heights for the North Pacific Ocean, we see a gale, pretty solid in size, with 27-foot seas pushing over the dateline, working its way towards the Gulf of Alaska. This is a good sign. Let's get into the details. First up, let's take a look at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When they do form, help direct their track. We're looking for troughs. That is a dip in the jet, just sort of like here. And also, like here, where that would help support counterclockwise flow aloft and down at the surface. And that, of course, is a sign of low pressure. Low pressure, of course, generates winds. Winds generate seas. Seas, when they radiate away from the fetch area, generate swell, which, of course, makes surf when it hits your beach. Right now, we have a nice little trough, nothing super significant. What is that, about 170 knot winds flowing into it. Supporting gale development there a little bit. But then notice the jet splits here, little well north of Hawaii, with most energy heading up into Alaska, and a trough, sort of a cutoff trough here off the U.S. West Coast, making for cloudy skies and low pressure, cutoff upper level low, basically. But that was also what generated rain. You can see this low right here, and backflow from it was generating the rain sweeping into central and southern California yesterday. That is pretty much fading out now. We'll put this into motion. The trough in the Gulf continues to the east, and this is what is also generating that area of seas we saw over the dateline today at 26 feet. That pushes into the Gulf, continues getting fed by about 170 knot winds into Tuesday and Wednesday. And notice this, the trough actually starts regenerating a little bit on Wednesday off the Pacific Northwest, pushing into Northern California on Thursday. So that should be good for some sort of gale development. Another trough here also, let's go back a little bit, starts developing Wednesday in the Northwest Pacific. A little bit of wind pushing down to it, but this doesn't look as organized. The winds kind of die out in its trough, and it's in the apex of the trough, and it's kind of pinched off, if anything. But still, maybe that's good to support something on Friday. And that continues off to the east. And then we still have, notice, not really a split jet stream, though. You see this patch of winds down here. It almost looks like the jet comes off Japan, splits, and some goes this way and some goes that way, but not super pronounced. And so and that was it. We're about 180 hours out. So the majority of the jet here by 180 hours starts creeping to the north up about 45 north, but still supportive of gale development. There's some sort of a split, something going on here, but nothing super marked in terms of, storm support for storm development, but certainly not suppressing it either. Let's go take a look down at the surface. And as we expected here, surface level pressure, surface level winds, 984 millibar low in the Gulf of Alaska, generating 35 to 40 knot winds, somewhat targeting Hawaii, and also the U.S. West Coast. This is, of course, the fetch that is generating the seas we saw earlier in the presentation, 26 feet just west of the east of the dateline. That system continues as expected into the Gulf into Monday, Tuesday. Also notice, much stronger than one would think, gale, actually a storm, 50 knot winds here west of the dateline on Tuesday from that sort of pinch trough over there. Anyway, roll this out. Also notice both systems now, two systems on Tuesday night, early Wednesday, one in the Gulf, one on the dateline, both with 45 knot winds. This one works its way Wednesday into the U.S. West Coast, and the one that was over the dateline sort of fizzles out a little bit, high pressure behind it. And here comes yet another system out over Kamchatka on Friday, making its way off to the east. But also notice with the jet stream further to the north, this system tracks further north, barely makes it to the dateline here, and is tucked up right alongside the western Aleutian Island, and then fades out, and that pretty much is it for the week. Though there is some suggestions of another low here, but with the jet being so far north and high pressure here pretty much taking over the dateline region, we suspect its track will end up in the Bering Sea. Let's go take a look at the wave models now. So we're going to go back in time a little bit first, go to Thursday, April 7th. Notice a gale developing on the dateline. Not super strong, but got 28-foot seas there on Friday, and then bumped up to 30 feet Friday about midday. Little bit northwest of the Hawaiian Islands here. Good for swell that is currently hitting Hawaii at this point, and also that swell is working its way off to the U.S. West Coast. And then midday Saturday, another far smaller gale, but with 32-foot seas, started developing west of the date line, working its way over the date line this morning with 30-foot seas. Let's go to the more current model now. Then current time, here we are, 27-foot seas, just east of the date line from that small gale, working its way into the Gulf on Monday, still with seas in the 23-foot range, and then building to 26 feet, 25 feet roughly, and then trying to build even yet a little bit more come Wednesday. 30-foot seas now forecast, 32-foot seas falling into Cape Mendocino on Thursday. That should be good for rather large but raw swell for the California coast. Then we go back again to Tuesday. While all that was going on over here in the east, another gale storm actually forms off of the Kuril Islands. What do we get out of that? Projected 39, well, probably 38-foot seas. Certainly good for swell aimed at Hawaii and the U.S. West Coast, but a bit far away for the U.S. West Coast. This thing finally pushes over the date line on Wednesday night. Seas falling from 30 feet, and that one quickly peters out, while yet another system develops Friday off the Kuril Islands, supposedly with 32-foot, 34-foot seas, and like we saw before, gets tucked up here along the western Aleutians and then peters out there, and then that's pretty much the end of it. So in all, a fairly productive storm track for this time of year. Take it for what it's worth, because at any point in time, we expect the whole storm track to fall apart, and we'll show you why in a minute. Also, we'll take a quick look at the southern hemi here. There was a swell that came out of this region, was that about a week ago, but since then, things just looking not nearly as productive. There is this sort of gale type thing formation, but forecast, this is good for swell. What is that? 26-foot seas, 24, 25-foot seas. Certainly good for Chile and Peru, probably up into Puerto Escondido, but probably not a whole lot for the U.S. West Coast. Southern California might see, actually, let's go back and just take a quick look here. There's a little bit of fetch, so about 118 west. That's in the Southern California swell window. Seas aren't really high, though, but still maybe some background swell will result. And then we'll just sort of roll this out. There is this other little fetch forecast here on Thursday, Friday, and this actually looks much better than what was projected on any earlier run of the model, so I'm not going to believe this quite yet. Need to see it show up for a couple of runs consistently on the model, but still 32-foot seas on Friday, aimed pretty well to the northeast and sliding northeast. That looks much better than previous indications. Maybe some swell could result out of that. So something to look for, but for right now, the focus is on the North Pacific. Now let's go take a look long-term what's going on with the remains of our El Nino and how it's influencing the weather and how it might potentially impact long-term swell production, specifically in the northern hemi. First up, let's take a look at surface level winds, specifically in the Kelvin wave generation area. That would be the area right around from about 140 out to about 170, 5 degrees north and south of the equator. Draw a box here. Clearly what we see is no west winds. If you see west winds here, that's typically a sign of the active phase of the MJO. If they're there for a long time, that suggests El Nino, and that's what enhances the jet stream in the North Pacific in winter months. We don't see any of that happening. If anything, we see strong trade winds taking over the entire equatorial region over the width of the Pacific. Now you look at anomalies here, you see little shades of westerly anomalies, but for the most, and you see little bits here, which is kind of interesting, given how strong the easterly winds are here. You wouldn't expect any of this to be literally anomalies, but supposedly it is. It seems a little bit maybe not right, but whatever. And we can take a quick look here. Again, the Kelvin wave generation area runs right around from here out to about here, just this little box, and this is up at the 850 millibar level, so about 4,000, 4,500 feet up. But that's a good proxy for what's going on at the surface. And in the Kelvin wave generation here, you actually see what appears to be easterly anomalies, except for this little area of westerly winds right in here. And that's been the case for the past 5 days. And now for the next week, we can take a look at the GFS model here, high-res version. And here is, of course, the Kelvin wave generation area, the dotted line, 5 north, 5 south. Date line is actually, where is it? Right here. So there's a little bit more of the Kelvin wave generation area here. But you can see east winds in the north in the 15 knot range or so. But south of the equator, basically a pretty light wind pattern. We'll just blow through this real quick. You can see not a whole lot of a change is forecast. Maybe the calmer winds take over a little bit more area as we get into the week Thursday, but nothing significant. Certainly no westerly winds. There's a little tiny pocket of westerly winds, but no wholesale westerly winds. Nothing significant forecast for the week. And yet, one other way to look at this is the whole globe on one chart. The date line runs right down here. Kelvin wave generation area starts over from about here to here, and you just draw lines right down the chart. Here's a westerly wind burst that occurred in March. Was this westerly wind burst number? It wasn't even really a westerly wind burst, just westerly anomalies. Maybe a little bit of true westerly wind burst there for a day, but nothing significant. And normally you saw this, you'd think, okay, maybe that can create a Kelvin wave, but it really can't. Because there is no warm water underneath it. El Nino has drawn all the warm water that was here in the West Pacific, pushed it off to the east, and now there's actually almost colder than normal water in this area. Anyway, here's the GFS forecast, starts here April 10th through the 17th, and you see a little bit of weak westerly anomalies. We assume that is attributable to the lack of winds. In the previous chart we just saw that there's no winds basically south of the equator in the Kelvin wave generation area. So that is what this is all about here. Just a slight westerly push, maybe a good little bit to help support the jet stream, but nothing really solid. So next we look to the state of the MJO, the Madden Julian oscillation, specifically in the Kelvin wave generation area. Again, right in here. When you see these oranges and yellow, that suggests more sunlight reflectivity. This is about outgoing long wave radiation in the Kelvin wave generation area. That means clear skies, high pressure. That means probably the inactive phase of the MJO. And here, more cloudiness. Therefore less sunlight reflectivity, and therefore the active phase of the MJO. So it appears to be in the Indian Ocean with the inactive phase taking over the Kelvin wave generation area, and that's basically forecast to continue for the next 2 weeks. Maybe a little bit of seepage per the statistic model of the active phase moving east, but not enough to dislodge the inactive phase. The dynamic model suggests pretty much the same thing. If anything, the inactive phase getting a little bit stronger 2 weeks out. So that's not really good for supporting jet stream development. But the models, there's a little bit of confusion on what's going on with the MJO, and we'll dig in a little bit deeper here. The phase diagram charts here, another way of tracking the MJO. So assume this is the North Pole here, and you're looking straight down on it from the top of the planet. And then as you go around from the Indian Ocean to the Maritime continent, over the date line, into the West Pacific, and then over the United States, and then into the Atlantic Ocean, and then back around the Indian Ocean. So basically that's a path around the planet. Where this dot is, or all these lines here, is previous places of where the active phase has been. Right now, here it is, smack dab in the Indian Ocean. Forecast to try to make it to the maritime continent, but notice this circle here. When you're inside this, as some people call it, the circle of death, basically means the MJO is extremely weak. The further out here, the stronger it is. So we have a active phase of the MJO in the Indian Ocean, extremely weak, forecast to make it to the maritime continent, then only get weaker and crash back to the Indian Ocean. The dynamic model, the GEFS or GFS ensemble model, basically suggests the same thing, so no real hope there either. So here's the CFS version 2 model. Here is past history, same sort of chart, date line runs right down the middle. Kelvin wave generation area, it runs from about here over to here, right up through the middle of the chart. And you can see Kelvin wave number 5 here, or actually westerly wind burst number 5 that was in January, westerly wind burst number 6 that was in March. Very strong indeed. And then you get here's where we currently are. You see really not a whole lot going on right around here. Yellows are westerly anomalies, blues are easterly anomalies. Now here's what's really interesting. You overlay the MJO, and the solid lines are the active phase of the MJO. And according to this model, we're in the active phase right now, which we find to be not very much true, and every other model suggests we're not. And it suggests Now that the inactive phase of the MJO is to hold from, starting about 3 or 4 days out into the end of April. Sure, that makes possible sense. And then after that, part of this really is there's just a very, very weak MJO pattern, so the models have a hard time getting a handle on what's going on. So we consider this to be a minority report. Either way, it suggests westerly anomalies building some in the May time frame, which seems probably not very likely. This model has been continually suggesting some sort of westerly anomalies coming, and they never come, and it keeps pushing it out. So that's a sure sign of a red herring when it keeps, pushing something good coming, but it just is always out of reach. So we suspect this is probably not necessarily true, and this whole model we're having a little less faith in lately. Anyway, so that suggests the MJO is weak. So here's a chart, subsurface temperatures, water temperatures, West Pacific here, East Pacific here. We've talked about westerly wind anomalies and the effect it may or may not have. Now, clearly you're seeing warm water here, subsurface, 29-degree temperatures, but they were pushing off over into this region a couple of weeks ago. They're retreating off to the west. This suggests that El Nino is losing its grip in a little bit at a time. And notice the 28-degree isotherm, which previously extended even last week the whole way over to the Galapagos, has collapsed and is retreat off to the west too. This just suggests that the warm subsurface pool that used to be over in here associated with El Nino is fading fast. In fact, you look here is actual subsurface temperature anomalies, and you can see there used to be a large pool of warm water here. We're down to 1-degree anomalies right here. Not very deep, 50 meters deep or so. That was down much deeper before. We had 3 and 4 and 5 and 6-degree anomalies over in this area. They're all but gone. One little shade of 2-degree anomalies, and what's striking here is below negative 3-degree anomalies racing subsurface, working their way. If anything, this is like a cold water Kelvin wave pushing its way off to the east. When that hits the surface, all our warm water is going to be gone, and it looks like the beginning of La Nina starting to take shape here. Also, from the Jason-2 satellite, sea level anomalies, strip out all the waves, strip out all the chops, strip out the tides. You're looking for a big bulge of warm water here. If El Nino or higher than normal sea surface heights in this area, that would indicate warm water at depth. Warm water at depth, of course, expands, pushes surface waters up a little, creating a bulge. We don't see any of that. If anything, we see negative anomalies, minus 5 centimeter anomalies, working their way east and continuing to build. This suggests that cold water is at depth and working its way in. And then finally, upper ocean heat anomalies, upper 300 meters the atmosphere of the ocean. And you can see these are warm anomalies here. This was Kelvin wave, Kelvin wave 2, I think it was. Kelvin wave 1 back in the spring of last year, Kelvin wave 2, Kelvin wave 3, massive Kelvin wave number 4 late last year, then Kelvin wave 5 the early part of this year, and then notice what's happening. All the warm water subsurface is literally all but gone. Now we're down to just 0 to ½ degree anomalies, and you see cold water here also working their way off to the east, making it to a point almost south of California now on the equator. Clearly a sign that El Nino is quickly fading away. So next we take a look at sea surface temperature anomalies, and clearly we still see a warm pattern here. There's been a lot of, we had a year plus of warming in this area, so this warm water that was here isn't going to dissipate, but it is already much cooler than what it was even last week. Looking at this, we only have 1 to 2 degree anomalies, one tiny little pocket here of maybe solid 2 degree anomalies, where this whole area was in the 3 degree anomaly range before, and the typical El Nino symptoms is like a tongue of warm water right here. It is quickly fading even in the past week. Nothing cooler than normal yet, which is a good sign, but temperatures definitely dropping off. And here we can actually zoom in. This is the high-res temperatures. So right in this area off Peru, this was all They're right along here. This was all 2.25 degree above normal anomalies here last time we looked last week. And then all out here out to about, the 120 range was all 2.25 degree anomalies. That's all vaporized now. There's barely anything left. And if anything, look at this, much cooler water starting to show up along Peru, off Colombia, and Ecuador. Not a good sign. That's suggestive of strong easterly anomalies here, which is normal for this area, but maybe even stronger than normal. The only warm water that's left is little pockets here and there. Just, you can see that El Nino is falling apart. And likewise, back to this chart, we have 1 degree anomalies, but just sort of here south of the equator now. They were all way out in here. They've retreated significantly in the past week. We have 1 degree anomalies still out here. What is this? From about Hawaii southward, and little pockets of 1.5 degree anomalies here, here, and here, but they're fading fast. It just looks like the whole warm pool is in a quick and certain demise. And this is the very striking image. You can see this is the sea surface temperature trend in the past 7 days, and look at this. Temperatures are crashing quickly right in the heart of the El Nino region. Nino 1, 2, working its way into Nino 3, and not quite, so Nino 4 or 3.4, which is what NOAA uses for tracking El Nino, still has a lot of warm temperatures out here, but you can just see with all those easterly anomalies, these cooler temps are going to quickly advect west over here and cut the legs out of El Nino. A quick look here at Nino 1.2 temperatures. Doesn't look so bad, a little bit of a dip. We still have 1 degree above normal anomalies, and that's pretty much what the charts indicate. But it just had, looking at the other charts, you sense that something big is about to happen in terms of the demise of these temperatures. And out in the Nino 3.4 region, out, more towards the date line, temperatures are holding their own at about 1.4 degrees above normal, which is kind of surprising given all the data we've seen. And even the Nino 3 region continues to slowly drift off, but still in the plus 1.4, 1.3 degree range. So, though things look like a stark decline is occurring, we still have above normal temperatures. Now here's the forecast for the Nino 3.4 region, and here we are in the April time frame. Temperatures are, the model here suggests it should be about 1.3 degrees in Nino 3.4, 1.2, and that's about where we are. But this chart has updated. It was previously saying temps would only go down to about minus ½ degree. Now they're suggesting a steep decline into the minus 1.7 degree range by December, which would put us clearly and strongly in La Nina territory. And the ensemble of a bunch of other models all suggest the same thing. So it looks like La Nina is on its way. But not to be too discouraged, the part of the deal here is that though the temperatures in the ocean are crashing, the atmosphere is still well coupled with those warm temperatures, and it's not going to change its style anytime too soon. It took the better part of a year to get the atmosphere reconfigured to support or to sense El Nino and to change itself around based on the warm temperatures that are there off the Galapagos. And it's not going to turn on a dime. It'll probably take 9 months to a year for it to totally swing back. So, interestingly, here we're looking at the Southern Oscillation Index. This is one measure of how well the ocean and the atmosphere are coupled. And the atmosphere is still suggesting, negative numbers here suggest the active phase of the MJO, and a long-running bout of negative numbers suggests El Nino. Currently, we still have pretty good negative numbers. Today's value is minus 2.6, but it's, as you can see here, since about March 24th, we've been negative, suggesting some form of active phase of the MJO was in control. The 30-day running average is still actually getting stronger negative, minus 6.89, and the 90-day running average, minus 13.54, though slowly coming up. This suggests that El Nino definitely is in play in the atmosphere, and some sort of weak active phase of the MJO was occurring, at least as far as the atmosphere was concerned. And then there's the ESPI, which basically does the same thing as the Southern Oscillation Index, but does it based on precipitation. Instead of differentials in pressure, it's the difference in precipitation north of Darwin versus difference in precipitation over the Nino region. Positive numbers suggest a good correlation to El Nino. The current value is 0.82. This has been steadily falling. It was up at about 1.5 a month or so ago, which is about normal for this time of year considering we're coming out of El Nino. And a slow demise into negative territory in this is also expected. But you can see precipitation still occurring over the warmer than normal water here, and drier conditions here over cooler than normal water. But over the next 6 to 9 months, we expect this to flop completely and reverse itself and go into negative territory. So, for now, a series of gales working their way across the Pacific, fueled by, I guess, what one might be able to call a weak active phase of the MJO, but probably not, probably more just by El Nino itself and the jet stream trying to hold on, trying to push out the last series of storms before we fully make the swing into spring. The recommendation would be make the most use of whatever swell results and get it for all it's worth, because it appears, looking at the long-term projections, that El Nino is dying. The jet stream will fall apart at some point. I mean, if nothing else, even forgetting El Nino, just seasonally, we're at the point in time where you better get anything you can. Season, on the best of years, maybe holds into about the mid-May time frame. So we still got a little bit left, but we're not particularly thinking that some massive storm is coming. It's just get what you can while you can. Clearly, looking at the long-term picture, water temperatures are fading in the Nino regions, temperatures dropping rather precipitously. Cold water is starting to build subsurface, working its way towards the Galapagos. We expect to see only a quicker demise and longer-term demise of those temperatures as we work towards La Nina. All the models suggest some kind of La Nina is coming for the fall. Atmospherically, it might take a while before that La Nina does anything. So if anything, the start of the fall might come on pretty strong and do well into about the November-ish, maybe early December time frame. And then La Nina will probably start to manifest itself in the atmosphere. Southern Hemi-wise, not a whole lot going on for right now. So take it all it's worth in the Northern Hemi right now. Make the most of it. And if there's any snow to be had, go get it while you can. We're definitely working our way towards spring in the Sierra. So that's it for this week. We'll do it again next week. Same time, same channel. Thanks for watching.